This video is on graphing equations using slope-intercept form. It is graphing linear equations. Linear means straight line. Every equation we graph will be a straight line. Slope-intercept form is y equals mx plus b, where the variable m stands for the slope and the variable b stands for the y-intercept. So we start with a form y equals mx plus b, but once m and b are replaced with actual numbers, we have what we need to graph it. Here is an example of an equation in slope-intercept form. Y equals 3/4 x minus 2. Before the x is my slope, 3/4. After the x is my y-intercept, -2. Step 1, plot the y-intercept. It says the y-intercept is -2. This is my y-axis. Here is -2 on my y-axis. That coordinate is 0, -2. So the first thing you would do is put a dot right here at your y-intercept of -2. Step 2, the slope is 3/4. Slope is rise over run. You rise up and down, you run left and right. So from this point, from my y-intercept, I'm going to rise 1, 2, 3, and I'm going to run 1, 2, 3, 4, and I'm going to put my second dot. In step 3, draw a line through your dots. And that is how to graph equations using slope-intercept form. I'm going to graph several examples for you. I'm only going to do one without graph paper just to show you that you can do it without graph paper. Here I have the equation y equals 1/2 x minus 1. My slope is 1/2, rise 1, run 2. My y-intercept is -1. If you don't have graph paper, just real quick, let's go maybe 3 in each direction. My y-intercept is -1, so I find my y-intercept of -1. There it is. From your y-intercept, you count your slope. This says I rise 1, I run 2. Rise 1, run 1, 2. Put your other dot, draw your line through it. We just graphed it. We just graphed an equation, or I just graphed an equation using slope-intercept form. And I can draw my graph that quick and graph it that quick. So if you have graph paper, maybe just draw you an X and Y axis on it. Use it. If you don't have graph paper, you can do it just like I did the last one. But let me do several examples for you here so you can make sure you have the hang of graphing using slope-intercept form. Again, slope-intercept form is y equals mx plus b. B is your y-intercept, m is your slope. Slope is rise over run. After the x is your y-intercept, on this one it says +1. Here's my origin. Here's my x-axis. Here's my y-axis. So +1 is my y-intercept. I put my dot there. From that point, I'm going to rise 2, run 3. Rise 1, 2, run 1, 2, 3. Boom, you could draw a line through it. But since we have graph paper, let's try to make it as neat as possible. So rise 2, run 3, I would be off the graph, so maybe I don't need that one. 2 divided by 3 is 2/3 or 0.6 repeating, and also -2 divided by -3 equals 2/3 or 0.6 repeating. So I could say rise -2, run -1, 2, 3. Rise -1, 2, run -1, 2, 3. Rise -1, 2, run -1, 2, 3. Just to give myself plenty of dots to make sure that my line is correct. Now, technically, you have arrows on the end of your lines because they go to infinity each direction, but not a huge deal if you don't draw those. Again, you only have to have 2 dots to draw a line. I like to do as many as will fit into my graph when I have little graphs like this, because you could be asked a question, you could be given, here's your equation, graph it and tell me the x-intercept. And so you have to draw your line straight to figure out that your x-intercept is right here at -1.5. Let's look at number 2. On number 2, my y-intercept again is +1. And my slope is -2/3. So I know my line will be going down if I read it left to right. I like to think of my negative sign on fractions as being in the numerator. So rise negative 1, 2, run 1, 2, 3. But you could also think of that negative sign as being in the denominator. Rise positive 1, 2, run negative 1, 2, 3. Rise positive 1, 2, run negative 1, 2, 3. Only 3 dots will fit in this graph. And there's my line. I know that my x-intercept is 1.5 and my y-intercept is positive 1. And if I want to, I can put those arrows, but it's okay if we don't. Number 3, my y-intercept is negative 2, negative 1, negative 2. My slope is positive 3/4. So I'm going to rise 1, 2, 3, run 1, 2, 3, 4. And I can also rise negative 1, 2, 3, run negative 1, 2, 3, 4. Draw my line, and I just graphed it. I will do 3 more examples. On number 7, my y-intercept is negative 4. Here's my origin, so I count down 1, 2, 3, 4 to the negative. And from there, I'm going to rise 7, run 4, because my slope is 7/4. So I rise 1, 2, 3, 4, 5, 6, 7, run 1, 2, 3, 4. And those are the only 2 dots that's going to fit on this graph. There's my line. And of course, these are not needed. I just wanted you to see how I counted. Number 8, y-intercept's 3, my slope's negative 1. So 1, 2, 3 is my y-intercept, and from there, my slope is negative 1, which is understood to be over 1. And again, your negative sign could go on the top or the bottom. So slope is negative 1, rise negative 1, run 1, rise negative 1, run 1, or rise positive 1, run negative 1, rise positive 1, run negative 1. When your slope is 1, it's going to go right through every single grid. When your slope is negative 1, it's going to go right through every single grid. So I don't even have to keep counting. I know that every one of these places where it goes right through the grid is where my line is going to go. When you have a slope of 1 or negative 1, it's going to go through every single grid without skipping one like other lines do. I instantly knew that my line was going to go down as soon as I saw that negative sign. Y equals 4x. There is nothing after the x, which means there's an understood 0 right there. I could write plus 0, but that would not be simplest form. The y-intercept is the origin. This line goes through the origin, and it goes through the origin positive. My slope is 4. That's understood to be over 1. So I'm going to rise 1, 2, 3, 4, run 1. Or I could rise negative 4, run negative 1 to make sure I have plenty of dots to make my line straight. The bigger the slope, the steeper the slope. 4 is a bigger number than 1 or negative 1. So a slope of 4 or negative 4 is going to be steeper than a slope of 1 or negative 1. And if you have a fractional slope, it's going to be shallow. If your slope is less than 1, you have a more shallow slope. Think about a slope of 1/4. Let's just pretend here's my y-intercept and have a slope of 1/4. Rise 1, run 1, 2, 3, 4. Rise negative 1, run negative 4. That is a shallow slope, 1/4. A steeper slope would be one like 7. If I have a slope of 7, and this were my y-intercept, I would rise 1, 2, 3, 4, 5, 6, 7, run 1, and I have a very steep slope. The further your slope is above 1, the steeper the slope, and the more fractional is, the more shallow is your slope. You try number 4. Number 4 gives you a y-intercept of negative 1, 2, 3. And the slope is positive 2, which is understood to be over 1. So I'm going to rise 2, run 1. I could draw my line and be done, but let's keep going. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I could also rise -2, run -1 to fill up my graph with dots to make sure my line is straight and correct. If I asked you what was the x-intercept, you should be able to look at your line and say the x-intercept is 1.5, 1.5. The y-intercept is -3, that was given. The x-intercept, we had to graph it to find, is 1.5 or 1.5. Try number 5. Instantly, I know I have a line going down. I have a negative slope. My y-intercept is -1. My slope is -3, which means I'm going to rise -1, 2, 3, run 1. -3 over 1. Or I could put the negative sign on the bottom, and I could rise +1, 2, 3, run -1. Rise +1, 2, 3, run -1. +3 over -1, -3 over +1. Doesn't matter. You end up at the same place with the same line. Try number 6. On number 6, my y-intercept is 2. And my slope is -1/5. Now I know this is going to be a shallow slope. I also know it's going to be negative. Rise -1, run 1, 2, 3, 4, 5. Or rise +1, run -1, 2, 3, 4, 5. We have a negative shallow slope. Y-intercept is 2. That's where you start. And from that point, you count your rise over run. Rise -1, run 5 in this case. We also need to be able to look at a line already graphed and write an equation from it. These are more likely to be more on a computer-based test. So let's look at one. If I want to write my equation in slope-intercept form, which again is y equals mx plus b, I got to find two things: the y-intercept, where it crosses the y-axis, and the slope, what's the rise over run from that point. So first thing I do is I find my y-intercept, -1. Maybe it's something you can write on, something you can't. I can write on this. I'm gonna go ahead and just put a dot there just to help save my place. And I'm looking for the next place that this line goes right through the grid. Not here, goes between two grids. Right here it goes to the grid. No, yeah. No, yeah. No, yes, no, yes. So it's going through every other grid diagonally. Now I really only need these two right here to write my equation, but just to check my work, I checked all of them. My slope is 2. Rise 2, run 1, rise 2, run 1, rise 2, run 1, or rise -2, run -1. Now, this equation shows a slope of 2, but a y-intercept of 0. That's not the case. My y-intercept should be -1, so I need to write that in. So my slope-intercept form is y equals 2x minus 1. Minus 1 is my y-intercept, where it crosses the y-axis. 2 is my slope. Rise 2, run 1. Number 2, find your y-intercept, which is -2. Next place it goes to the grid is here. Now I could also identify here, here, and here if I wanted to, but I really only need those 2 points. Y equals, my slope is -1 over 2, and my y-intercept is -2. Also, make sure you always go back and look. My line is going up on number 1, so make sure that's a positive slope. My line is going down on number 2. Make sure that's a negative slope. Number 3, I instantly know that's a positive slope. I want to make a note of that, make sure I don't make a mistake. Or in a multiple choice test, I can eliminate any negative slopes instantly. Goes right through the grid here. No, 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 yes, and right here. Now I could find some more points, but those are the only ones I need. rise 1, 2, run 1, 2, 3. My slope is 2/3, and my y-intercept is +1. So slope-intercept form is y equals 2/3 x plus 1. Try number 4. Try to write that in slope-intercept form. Goes through the grid here. On my y-intercept, the next place it crosses the grid is here. I can also identify here if I wanted to, but this is all I need. I'm going to rise 3, run 1. So my slope is 3, and my y-intercept is -3. Your answer is y equals 3x minus 3. Try number 5. My slope is -2/3. Got to be negative because it's going down. My y-intercept is +3. Try number 6. My y-intercept is the origin, 0. My slope is rise 4, run 1. Goes through the grid here, here, and here. So slope is 4, y-intercept 0. I don't write that, it's understood. Your answer is y equals 4x with an understood y-intercept of 0. Try number 7. Number 7 has a y-intercept of 0 and a slope of 1. Rise 1, run 1, rise 1, run 1. We don't write 1x because the 1's understood. We don't write plus 0 because the 0 is understood. So we would not write y equals 1x plus 0, not simplest form. That's understood and that's understood. So this equation is y equals x. That would also be a good one to illustrate a table on. Think about this. If I plug in 0 for x, I get 0 for y. If I plug in 1 for x, I get 1 for y because they're all equal. 2 for x, 2 for y. And if I plotted these points on the coordinate plane, 0, 0, 1, 1, 2, 2, 3, 3. That's another way to graph it, using a table. And that one would be an easy one to use a table on. Try number 8. Number 8's a little bit tricky. It's only tricky because you haven't seen one before, but think about it. Your y-intercept is 2. And what's your slope? What do you rise? You rise 0 and you run, it really doesn't matter because 0 over anything simplifies to 0. So I would not write y equals 0x plus 2. I would just write y equals 2. I have a y-intercept of 2 and a slope of 0. Anytime you have a horizontal line, wherever it goes through the y-axis, your y-intercept, you just write y equals that number. So if I had a line right here, that would be y equals -2. If I had a line right here, that would be y equals -5. Horizontal lines are just y equals whatever the y-intercept is. And vertical lines are just x equals whatever the x-intercept is. This vertical line has a x-intercept of 2, so my equation is just x equals 2. Technically, this is not slope-intercept form, but this is the equation. Horizontal lines have 0 slope. Whatever the y-intercept is, your equation is y equals that number. Vertical lines have an undefined slope because you rise whatever you run 0, and you can't divide by 0, your calculator would give you an error. Unlike over here, 0 divided by 4 equals 0. 4 divided by 0 is undefined, can't do it. So horizontal lines, 0 slope, y equals whatever the y-intercept is. Vertical lines, undefined slope, your equation is x equals whatever the x-intercept is. So if this were my vertical line, then my equation is x equals -4. I'm going to let you try a few. Try number 10. Number 10 has a y-intercept of 0. It goes through every single grid in a negative way. My slope is rise -1, run 1, rise -1, run 1. The equation is y equals -x. Your slope is -1. Your y-intercept is 0. Try number 11. If you have a vertical line with an undefined slope, your equation is x equals whatever the x-intercept is. In this case, x equals -3. Try number 12. If you have a horizontal line with a 0 slope, your equation is y equals whatever the y-intercept is. Vertical lines, x equals the x-intercept. Horizontal line, y equals the y-intercept. Try number 11. Sometimes we have to write an equation for a line and we can't draw our little dots where we want to. We just have to be able to look at it and see where does it go through the grid. Try number 11. Number 11 has a y-intercept of 2. It goes through the grid right here at the x-intercept of -3. It goes through the grid right here at the coordinate 3, 4. Rise 2, run 3, rise 2, run 3. Your slope is 2/3. Your y-intercept is +2. So your equation is y equals 2/3 x plus 2. Try number 13. Number 13 is x equals -2, and it has an undefined slope. On number 12, I instantly know I have a negative slope, I have a positive y-intercept, and I have a real shallow slope. It's going to be a fraction. Try number 12. It goes through the grid at the y-intercept of +1 and again at the x-intercept of +5. So you will rise -1, run 5. Your slope is -1/5 and your y-intercept is +1. Y equals -1/5 x plus 1. Try number 14. I instantly know I have a negative slope. It goes through the y-axis at your y-intercept of 3. The next place it goes through is at your coordinate 1, 1. The x-intercept's 1.5, so I don't want to use that. It goes right through right here at 1, 1. So your slope is -2 over 1, -2 over 1, all the way down. Your slope is -2, your y-intercept's +3. Y equals -2x plus 3. Try one more before we move on, number 35. Number 35 has a y-intercept of -1, 2, 3. It goes through the grid here, 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 and here. Every time you rise 1, run 2, rise 1, run 2, rise 1, run 2, it goes through the grid. Your equation is y equals 1/2 x minus 3. Here we have a quadrant 1 graph. Most word problems use quadrant 1 graphs because most word problems involve positive numbers. Most word problems involve time or money, and time and money really can't be negative. So most word problems have a quadrant 1 graph. Before I show you the equation for this, you just think about it in your head. What do you think the equation for this graph is? Find the y-intercept and find the slope. My y-intercept is 4. My x-intercept is 8, but I don't need to know that. My y-intercept is 4. It goes to the grid here, and here, and here, and here. Every time you rise -1 and run 2, it goes through the grid, and then your y-intercept is +4. Now, some people might have counted from this 4 to this 8. Well, if you rise -4, run 8, that simplifies to negative 1/2, and that would have been fine. Let me show you a word problem that I've already worked out. But the word problem was a video store charges $10 for a rental card plus $2 per rental. So it said write an equation in slope-intercept form for the total cost, C, of buying a rental card and renting M movies. The total cost, C, equals $2 times however many movies I rent plus $10 up front for rental card. That is slope-intercept form. Y equals slope of 2, x plus y-intercept of 10. It told me to use variables C and M, but it's slope-intercept form just like if that were y and x. Y equals 2x plus 10. It told me to use C and M, so C equals 2M plus 10. My y-intercept of 10 is my starting point. I have to pay $10 up front, plus I pay $2 per rental. I'm going to rise $2 every time I get one rental. So I graph the equation. My y-intercept is 10. That's what I start at. At 0 movies rented, I got to pay $10 for my rental card. I rise $2 per one movie, rise $2 per one movie, rise $2 per one movie, and I can graph this equation. Now I'm only rising one box, but notice the boxes are worth $2 each. So rise $2 would be one box. Rise $4 would be two boxes. This is a positive slope, positive correlation. The more movies we rent, the more money it costs. And it says, find the cost of buying a rental card and renting 6 movies. I can take this equation and plug 6 in for the amount of movies. 2 times 6 is 12. 12 plus 10 is 22. So the answer is $22. Or I can look over at my graph, look at 6 movies, go up and look, where does it cross the graph? Right here at $22. So the graph should match the equation if you work it out. And again, most word problems are quadrant 1 graphs. Everything's in quadrant 1 because the numbers usually are going to be positive. Let's look at one more word problem. Carla has already written 10 pages of a novel. She plans to write 15 additional pages per month until she is finished. So I could start out thinking it this way. She's wrote 10 pages plus 15 pages per month. If I wanted to write an algebraic expression not giving any information other than this paragraph, I would have probably written that. $10 plus 15, I'm sorry, 10 pages plus 15 pages per month. It says write an equation for the total number of pages P written after any number of months M. So total number of pages equals 15 pages per month plus 10 pages already written. There's my equation in slope-intercept form, and here's my graph. The boxes are worth 20 up and down, so my y-intercept of 10 has to be right between 0 and 20. My slope is 15, so if I rise 15 from 10, that's going to put me at 25 over 1. Rise 15 more from 25 to 40, 15 more up to 55, then to 70, then to 85, then to 100, then to 115. I'm rising 15, running 1 every time. Let's look at a multiple choice. My equation is y equals 5x minus 2. So instantly I'm going to look for a y-intercept of -2 and a positive slope. Here I have a y-intercept of -2 positive slope. It could be A. Can't be B. It has a y-intercept of +2. I'm looking for a y-intercept of -2. C and D both have negative slopes, so I know they're wrong. B has the wrong y-intercept. Without me even counting rise over run, it has to be A because it is the only one with a y-intercept of -2 and a positive slope. But I'll count it just in case. Rise 1, 2, 3, 4, 5, run 1. Yep, right on the grid. This one has a y-intercept of -1, a positive slope of 4. So I can rule out B, it has a negative slope. I can rule out D, it has a negative slope. It's either A or C. And I'm looking for which one of those, A or C, has a y-intercept of -1. A does. Let's check C. Nope, C's got one, a positive 1. So without even counting slope, I know A is my answer. My y-intercept's -1, my slope is 4. Rise 1, 2, 3, 4, run 1. And we'll do one more. +4 y-intercept, +2 slope. It can't be C or D because they both have negative slopes. It's either going to be A or B. Does only one of those have a y-intercept of +4? Yes, B does. It has a y-intercept of +4. A has a y-intercept of -4. So I know that's my answer, and I can count my slope just to make sure. Rise 4, run 2, which simplifies to 2, or rise 2, run 1, rise 2, run 1. Even if I don't do that, even if I don't count it, I can get the right answer. So the slope-intercept form of a linear straight line equation is y equals mx plus b, where m is a slope, b is a y-intercept. When you graph, start with your y-intercept, put a dot there, and from there count your slope, which is rise over run. And that is video 1 on graphing equations using slope-intercept form. Thank you.